All right, so let's continue on with the peripheral nervous system. We talked a little bit about the central nervous system, which is the brain, spinal cord, but what about everything outside of that? That is our peripheral nervous system. And there's quite a bit when we get into the peripheral nervous system, including the autonomic nervous system, dealing with sympathetic, parasympathetic. Those will play a little role into that. That is a separate lecture. We're just going to be talking about really the nerves outside, a lot of the cranial nerves, as well as various different things called plexus, the plexuses of the body, and how the nerves work through there. Okay, so our peripheral nervous system is really important because we're dealing with this link between the outside world to our inside world. This is all the sensations that we feel, all the different receptors that we take that information to our central nervous system, specifically our higher brain, so we can process the world, process our environment, and create a response to that environment. Um, and there is some bypasses of higher learning, which we call reflexes, that we'll get into as well. All right, so that's what we are going to talk about. So let's jump into it. Peripheral nervous system lecture for this. Now, peripheral nervous system is all the neural structures outside the brain and spinal cord, right? And we are definitely dealing with tons of sensory receptors, our peripheral nerves, but we also deal with the motor responses, like all the process that we see from the sensory. How are we going to respond? Are we going to use skeletal muscle to run from the bear? Are we going to be sending sympathetic, parasympathetic information to our glands and our visceral organs? All those things are dealing with our peripheral nervous system. We have motor endings. That's going to be our response. And then we have these things called ganglia, and ganglia are clusters of our cell neurons bodies through there. So we'll talk quite a bit with that as well. Okay, so the function of the peripheral nervous system is to provide a link from the outside world to our inside world, just as I was talking about, and begins with dealing with sensation. Okay, so here's the breakdown of our peripheral nervous system. We're going to have a motor response as well as the sensory reception for that. Our motor response, we're going to have some conscious awareness. The somatic nervous system may a lot with our skeletal muscle, but there's a huge portion where it's automatic, which we call the autonomic nervous system. That's our sympathetic and parasympathetic. But let's look at this sensory division first. The sensory division, we deal with all kinds of receptors, and there's various different types of receptors. Here's just a handful of them. Mechanoreceptors. Mechanoreceptors measure movement. So the body doesn't know what high blood pressure is. Instead, what it does realize is when we get pressure in the blood vessels, it pushes on the vessels themselves, and the vessels feel that motion, that stretch. Those would be a mechanoreceptor. The mechanoreceptors measure stretch. They measure vibration, touch, pressure, all those kind of things dealing with movement, changes to tissue. Then we have our thermoreceptors. Thermometer, like temperature. That's going to be doing temperature changes, how we can tell hot from cold. Photoreceptors, dealing with light, mainly in our eyes, the retina, the back of our eyes, dealing with light input there. Chemoreceptors, measuring chemicals. Our smell sensation, those are actually chemicals that get into the olfactory nerves that stimulate smell. Chemoreceptors also for taste. We'll also have receptors that measure chemicals inside the blood that help regulate different blood levels of sodium, of calcium, those kind of things. Calcium, dealing with the different chemicals in the blood to make sure we create homeostasis. And then we have nociceptors. Nociceptors measure pain, and they respond to potentially dangerous things in our body. So various different receptors. Now, we break down a lot of these receptors into what we call externoreceptors, internal-receptors, and proprioceptors. We've heard of proprioception. Proprioception is this idea of being able to recognize ourselves in space and time. Proprioception is what happens when we're walking downstairs and a stair or a step is an inch shorter. Like we feel that internal change in our body. It's mainly in our skeletal muscles, our tendons, our ligaments. And they are letting us know where we are in space and time. Versus our external and internal receptors, they're just like what they sound. External receptors are measuring input and stimuli from the outside environment to our body. They're near the surface of the body. They're dealing with touch, pain, pressure, temperature, a lot of stuff on the skin, vision, hearing, smell, equilibrium, those kind of receptors from the outside world that we're going to deal with. Versus our inside environment is dealing with like our visceral organs, dealing with our blood vessels, the chemical changes within, the temperature. This is where we feel hunger, thirst, those kind of internal awareness of what's happening. Okay. Proprioceptors, that proprioception is a lot, as I mentioned, in our joints, our muscles, the connective tissues, dealing with input of where we are in space and time. They deal a lot with the mechanoreceptors, so they're going to be dealing with that movement, and their function is to constantly advise the brain to our body movements. That's what I mean by recognizing where we are in space and time, letting us know our body movements. What allows me to close my eyes and touch my finger to my nose, right? It's that proprioception. So let's talk a little bit of the structure of our nerves. Now, this endo, peri, and epi might sound familiar, the endomysium, the perimysium, epimysium, right? The endosteum, periosteum, like those kind of things. Well, much like the muscle, if you recognize the names from the muscle, it's just like that with nerves, where you have a bunch of single nerve fibers. This would be the axon of one nerve, and it is surrounded by a connective tissue called your endoneurium. And then we get a big cluster of a bunch of axons, and we wrap all those together in a bundle called a fascicle, just like it would be called in a muscle. That fascicle is wrapped with perineurium. And then you wrap a few fascicles all together, and you wrap all that into one big nerve called your epineurium. Now, in between a bunch of these fascicles, you'll also have some blood supply and some artery, vein, nerves that are going to be going throughout the entire body. But you can see a nerve, which is going to be one of these, is made up of many fascicles, which are made up of many neurons and their axons through here. Now in here, if in our nerve, we're going to have some neurons that are going away from the central nervous system, dealing more with motor control. And then we're going to have some going to the central nervous system, dealing with sensation. And that is sensory, coming towards the central nervous system, your afferent neurons. Your motor is your efferent neurons. So some nerves are going to be strictly sensory, some nerves are going to be strictly motor, and then some are going to be mixed. So when I say nerves, it's a bundle of a bunch of neurons, right? So some nerves are going to have strictly sensory, some are going to be strictly motor, and then some are going to have these bundles going back and forth to and from the central nervous system. We call those mixed. When we get a cluster of these nerves, bunch of axons will come down, but the nerve body, the soma, is a little bit bigger, right? It's a little bit larger on that. And so when we look at a neuron, let's look at a neuron. I don't have an actual picture of a neuron here. Actually gonna pull one up. All right, so if we're looking at a bundle or a neuron, remember the axons are nice and long and skinny, but here we have the soma, the body, they're a little bit bigger and bulged. So if we have a nerve, which looks nice and beautiful, we're gonna have this long nerve, which is gonna be filled with a bunch of neurons, right? Well, if we have a cluster of these bodies, we're gonna see an enlargement where the cell bodies are, right? And a cluster of nerve bodies of the peripheral nervous system, if you remember, those are called our ganglions, a ganglion. And that is a cluster of these nerve bodies, these neuron bodies in here, okay? So that is what we're dealing with here, the ganglion or ganglia, plural of that, right? So what we have is we have on our peripheral nervous system really two, I'd almost call them like three different ganglions that we look at. Here they listed two. The reason why I say three is the autonomic ganglia. We have sympathetic and then parasympathetic. Those break down a little bit more. Our dorsal root ganglion, if we look at a neuron and where they're coming out of a spinal cord, we're going to have some that come off more anterior and more posterior. Dorsal root ganglion is also called a posterior root ganglion. You will rarely see it called a posterior root ganglion. It means the same thing, but everybody says dorsal root ganglion or dorsal root ganglia, right? And that is our sensory nerves. So we have all these nerves coming back from our body, and right as they start entering into the spinal cord, we're gonna see those cell bodies, the neurons' bodies, form a ganglia. And that is what we call the dorsal root ganglia. Versus our autonomic ganglia. The autonomic ganglia, depending if it's sympathetic or parasympathetic, they're in different parts of the body, but they're still clusters. So we will get into that more when we deal with the autonomic nervous system. But if you can see this slide through here, this would be our sympathetic trunk ganglion. There are clusters of cell bodies and they sit just outside the spinal cord in the thoracic region. That would be the sympathetic trunk ganglia. The parasympathetic, the ganglia are a lot closer to the actual organ of wherever it's going to. So we'll take a look at that when we get into the autonomic nervous system. But just so you know, that's kind of what we're looking at when we're dealing with ganglia. Another thing to be aware of when we're dealing with our nerves, we have the neurons, the nerves, the ganglia. With our ganglia, let's see here, I don't want to say anything else on that. The dorsal portion of that, as I mentioned, is your sensory. That is also going to create more of what we call little roots. They're little branches of the nerve. So sensory comes in from the posterior part of the spinal cord. The anterior part of the spinal cord is more efferent motor response, and we call those roots. So the dorsal root or the dorsal rootlets will be dealing with sensory. Ventral or anterior is dealing more with motor efferent fibers. Ventral horn versus dorsal horn, you'll see that in lab a little bit more when we look at cross sections of our spinal cord. Okay. What's also interesting in the peripheral nervous system is we can get some regeneration of nerve fibers. Remember, I said a lot of nerves are amitotic, meaning when they die, they die. Well, a lot of them are, especially in when we're dealing with the peripheral nervous system. However, we can damage axons, and the axons can regenerate. We don't see this in the central nervous system. So we can get a complete damage of that axon, and we can get some of that to regenerate, which is kind of a cool process that we see. So these slides just show what's happening in that process of helping regenerate. You don't need to know the steps, just know that there is some regeneration of the axon in the peripheral nervous system. Okay, so now let's get into the actual different types of nerves. Want to begin with cranial nerves. Cranial nerves is a big portion of this lecture. It's a big portion in lab as well. Now, as I will talk about these, I'm going to go through them a few different ways. Keep in mind that there is 12 pairs of cranial nerves. Most of those arrive from the brainstem themselves, which we kind of talked about, except for the first two. And when we're dealing with cranial nerves, you're going to see some, if I go back to, where was it? The classification, the sensory, motor, and mixed, you're going to see some cranial nerves that are just sensory, some that are just motor, and then you'll see some that are both sensory and motor. And when I say just, I should say majority sensory, majority motor, because we're dealing with some proprioception, which is a type of sensation on most of them, but we still classify it as primarily sensory, primarily motor, or quite a bit mixed. So we're going to break down this classifications of the cranial nerves. Okay, so 12 cranial nerves. They have the sensory, motor, or both sensory and motor. We call that mixed. 4 of the cranial nerves carry parasympathetic fibers. And those parasympathetic are going to serve various different muscles and glands in the body, which we'll see. So if we look at the underside of the brain, as well as the spinal cord, which would come down through here, before it gets in the spinal cord, here is your brain stem, right? Where we have all these different cranial nerves coming off. And cranial nerves are named by both an actual name as well as a number. So we're going to go through these charts where you'll see 1, 2, 3, 4, 5, 6, and I'll go all the way down to 12 through here, okay? You're going to see the name of that nerve, as well as over through here, you're going to see whether it's motor, sensory, or both. Now, here's what I mentioned before, where you're going to see a lot of them will have some sensory, where it says proprioception. We don't count that as an actual sensory nerve. Just recognize that it does have some proprioception properties. Look at the bold. You see these bold? So cranial nerve 12, which we call hypoglossal, is primarily motor. Accessory, primarily motor. Tiny bit of sensory, but we don't call it a sensory nerve. Versus some of these that, like the vagus nerve, number 10, it is a mix because it does both motor and sensory, okay? The PS are your parasympathetic ones that I talked about being 4 of them. 1, 2, 3, and 4. Those are the 4 nerves that deal with the parasympathetic. Yes, you do need to know those. Ocular motor, facial, and your glossopharyngeal and your vagus nerves are your parasympathetic ones, okay? Now, let's look at what they do and whether it's primarily motor, sensory, or both. Here we go. Let's look at underneath here, and this will help with lab as well. And they're labeled just in order. So these long guys through here are your olfactory nerves. The olfactory, which I'm just right now gonna go based on numbers of how I teach you this, okay? 1, 2, 3, I'm gonna go just down one side because remember they're paired. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, this long one, 11, and then we come to the front, 12. Simple as that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Pretty straightforward. You'll be able to find those. You need to know those and where they're located for lab exam. You also need to know the names of those, okay? So let's look at all these really quickly, but you do need to know these quite a bit more in detail, okay? We're dealing with olfactory. What does it do? It's sensory. It's just dealing with smell. Optic, dealing with vision, seeing things. Sensory, sensory. Where your ocular motor is, yeah, has a little bit of sensory, but again, we're not counting the proprioception as a sensory portion. And it has some parasympathetic dealing with the iris lens, which will cause constricting of the iris. But you can see here, this is ocular motor movement, and it is dealing just with the motor portion of that. There is 4 main muscles in the eye. We will get into the eye when we deal with special senses, but what it looks like, just so you know, here would be the eyeball, and there's muscles on the lateral side of the eye, the medial side, which is this guy right through here, superior, inferior, and then we have these 2 oblique ones. So this, actually, let me get this much bigger so you can see. Sorry about that. So lateral, medial, inferior, superior. Those are pretty straightforward. So you can think about, if I have a muscle on the top part of my eye and it constricts, my eyes are going to go up. If I have a muscle and it constricts and it's down on the bottom, I'm going to look down. If the lateral one contracts, this eye will go lateral. If the medial portion constricts, it would go medial. So there's different muscles that just move the eye. You don't have to know all these muscles quite yet, but you will have to get it when we get into special senses, so you might as well start learning them right now, okay? So those are your rectus muscles through here, but you're gonna see these guys. This is what we call the superior oblique, and it comes along through here, and there's this little loop, and it comes across the eyeball, and it will turn the eyeball and go some strange directions. I'm not going to get into all of that right now, but there's a superior oblique and an inferior oblique. It would be awesome if there was one nerve that controlled all those eye movements, but it's not quite that simple, unfortunately. So you're going to have to learn them however way makes sense for you. So the ocular motor, cranial nerve number 3, is motor to the eye, but it only does 4 of those muscles. It does the medial, inferior, and superior rectus muscles, as well as your inferior oblique muscle. Okay, that's your ocular motor. That is a big portion. Oculio, meaning eye, and the motor movements, it's the nerve that controls most of the movements of the eyes, but not all of them. Versus here is another movement of the eye, the superior oblique, and we call that the trochlear movement through there, and that is just motor. Trigeminal, the trigeminal nerve is motor and sensory, and that's dealing with a lot of sensation on our face, different sensation on the face, and a lot of our chewing muscles. So trigeminal, a lot of the facial muscles through here. And then that brings us to the last of the eye ones. Your lateral rectus is called your abducens. It is just motor through here, cranial nerve 6. Cranial nerve 7, you can see 2 highlighted, it's mixed. Facial, dealing with a lot of the facial expressions, and it deals with taste from the anterior 2/3 of the tongue. Okay, and then a little bit of your parasympathetic nervous system dealing with these glands. 8, vestibulocochlear. The vestibulocochlear, we're going to get in way more detail of that, but this is your ear. And your ear does dealing with the division, or the division that's dealing with balance and equilibrium. That would be the vestibule portion. cochlear, like a cochlear implant, if you ever heard of that, that's dealing with hearing. So then you're dealing with the hearing portion of the ear as well. Vestibulocochlear, both, or sorry, just dealing with the sensory of both the vestibule and the cochlear division, the balancing equilibrium and the hearing division of the ear. The ear does two different things that we'll get into quite a bit when we get into sensory. Just a little foreshadowing, I love the ear. The ear is such a fascinating organ, crazy stuff going on with that. All right, and then we have your glossopharyngeal that is dealing both mixed. It is motor and sensory because we're dealing with the muscles of the tongue and pharynx. So our throat, the movement of our tongue, but it's also dealing with the taste on the posterior part of the tongue. We dealt with taste on the anterior 2/3. Now this is that posterior portion of that. The parasympathetic is your parotid gland. And then we have our vagus nerve. Now, our vagus nerve, the vagus nerve, there's so much cool stuff happening with the vagus nerve, and it controls tons of stuff, tons of stuff. But right now, this is all I want you to know for that. It is a mixed nerve. You're dealing a lot with the larynx as well as the pharynx muscles. You're dealing with taste in the back of the pharynx, a lot of proprioception of our body. Notice how we talked about a lot of those other ones have some proprioception. Here, the vagus nerve is a big proprioceptive input for our entire body. Pretty cool. And then the parasympathetic division of this is our heart beating, our lungs breathing, all the digestion that's happening in our body, like tons of all the abdominal and rest, digest stuff of our body is our vagus nerve. We want to really take care of our vagus nerve through there. Okay, and then that brings us to the last two, both motor is 11, your accessory, and is muscle control of the sternocleidomastoid muscles, your trapezius, but it's also some motor function of the throat, your larynx, soft palate. And then the hypoglossal is muscle movement of the tongue, motor. So how in the world are you going to try to memorize all this? This gets a little tricky. Before we get into that, this little chart is really nice because it shows the 3 different nerves that control the eye movements and what muscles they are. So here we have the 4 different rectus muscles that are pretty straightforward, and your 2 oblique, and the division of all those and what they do. You might as well start memorizing this chart before we even get to the eye, so therefore it'll really help when you get to the eyeball, okay? All right, so let's look at this cranial nerves and how we're gonna memorize that. Let's forget these divisions. For now, I want you to, this little portion, we're just gonna try memorizing the 12 cranial nerves and their names. And the way we do this is a little acronym, what we call OOO. To touch and feel good velvet, ah, heaven. OOO. To touch and feel very good velvet, ah, heaven. Let's look at that. OOO. To touch and feel very good velvet, ah, heaven. Good way to help memorize it. If that works for you, great. And then going from there. Now, to go in that same order, how do we memorize these? And again, we're just looking at what its primary thing is. So sensory, motor, both, motor, both, right? So there's a bunch of different acronyms on this. The one that I use is some say marry money, but my brother says big brains matter more. Some say marry money, but my brother says big brains matter more. Good way to memorize it. There's some other ones out there, but those are my two that help you memorize that. Okay, so that is your cranial nerves. Let's delve into the rest of the peripheral nerves. Now, there's tons of nerves that are coming off our spinal cord, right? And those are our cranial, thoracic, lumbar, sacral, and coccygeal. And they are 31 pairs of mixed nerves, meaning sensory and motor, right? Because we're dealing with sensory coming a little bit more anterior into the spinal cord, or sensory posterior, motor more of that anterior ventral portion. So there's these mixed nerves, and they're going to be branching off. Now, the cervical region has 8 different spinal nerves, paired spinal nerves. Thoracic 12, lumbar 5, sacral 5, coccygeal, we call it just this off the one coming off through there, okay? Now here is a good way to remember it. Thoracic vertebrae, 12. Lumbar vertebrae, let's look at thoracic vertebrae, 12. Lumbar vertebrae, 5. The sacral is 5 fused, and then we have that little coccygeal one, right? The only really tricky portion of that is the cervical only has 7 vertebrae. Well, there's 8 nerves. How is that? Well, here's how it works. These nerves are named according to where they come out, and it's named underneath the vertebrae in which they come out. Okay, so they're gonna come out of those. So let me show you what that looks like from this standpoint. Sorry, let's try that one more time. From this standpoint, there we go. Okay, so here would be our nerves coming off of our spinal cord, okay? So if we looked at here, this is the top portion of our head, and let's put our skull here, because of course we have a big melon sitting on top of our head through here, okay? So pretend like this is a skull. Well, let me get here. Let's get a little pen. And here. Between the skull and the first vertebrae, we are going to have a nerve coming off there. Between C1, C2, we're going to have a nerve coming off there, and then they start coming out in between each of these vertebrae all the way down the spine. And again, they're paired, so they're going to be coming off both sides through here, okay? All right. So if we're naming those, the first one coming off, it is between the skull and C1. We're going to call that C1. We're just going to name those. So that would be the cranial nerve 1. And then we have 2, 3, 4, 5, 6, 7, 8. And then we get into T1, 2, and then that would be going down. So now look at this. Here is our C7, right? And we name them underneath. So that's still a cervical nerve because it's coming underneath that one. The cervical is a little bit different because C1 is actually coming off the bottom of the occiput and C1. So we name all those from here, from thoracic all the way down. T1's coming off the bottom of the T1 vertebrae. T1 nerve, T2, here would be T3, and so on. And that travels all the way down. Goes all the way down. So we're here dealing with nerves. Here would be your L4 nerve, L5 nerve, and then we're going to have your sacral nerve, sacral 1, 2, 3, 4, 5 off through here, and then your coccygeals through here. So that's how we name our nerves. Okay. So back through here, your 8 cervicals, 12 thoracic, 5 lumbar, 5 sacral, 1 coccygeal nerve. Now, Off those nerves, we have short little branches. So those nerves are going to be coming off in between those vertebrae. And then there's going to be some tiny little branches before they travel all the way down throughout the rest of the body. And those little branches are called rami. And they're little nerve branches. And there is some which go to the posterior part of that spine, and we call those dorsal rami or a dorsal ramus. They're a lot smaller versus the ones that go more anterior. They're going to deal with the muscles and the skin around the posterior trunk, as well as the anterior portion of the body. So if we look at it from this standpoint, those nerves are branching off out of the vertebrae. They're going to go and travel throughout the body. Cervical will go down my arm. My lumbar are going to go down my legs, right? Well, you can see there's some branches off through here that will control some motor and sensory off my posterior portion, and they're right there. The posterior muscles and skin are right there, so they're shorter versus the anterior ventral ones. They're a little bit longer because they have to go all the way around into the front, dealing with the skin and muscles of that region. So they're a little bit longer to and from the remainder of the body. So those are our rami. Now, those branches, if they go further, they are going to come and combine together and be called plexuses. Now, a plexus is a bunch of nerves interlocking with these rami, okay? So all the ventral rami except T2 to T12, so the cervical, the lumbar, the sacral, all those branch together and form plexuses. And then those plexuses are grouped together in what we call cervical, brachial, lumbar, and sacral regions. How does that look? It looks like this. So here would be a cervical plexus. These are the cervical nerves. The branches come together and all the branches connect and form various different nerves. And the big nerve that we want to know for our cervical region is our phrenic nerve. That is one of the main nerves. Now, our phrenic nerve is made up of C3, C4, and C5. They branch together and form a specific nerve called the phrenic nerve, and that affects your diaphragm. So this is the breathing. This is the nerve that controls breathing. Cervical plexus is made up of a bunch of ones, and there's other nerves that go, but the phrenic nerve is the main one I want you to know on this one, okay? And it's dealing with a lot of the skin around our neck, ear, back of head, shoulders, the diaphragm. Those are the things that we know from that. C1 through C5, the phrenic nerve is C3 through C5. Now, the brachial plexus. The brachial plexus is formed by C5 through T1. So C5, C6, C7, C8, and T1. So if you look over here, here we have C5, 6, 7, 8, and T1. They do little branches, and then those are going to form various different nerves. There are quite a bit of nerves that come off this brachial plexus. I want you to know these 5 nerves: the musculocutaneous, axillary, median, ulnar, and radial. The musculocutaneous is motor fibers to the biceps brachii and the brachialis, and it's dealing with sensation, dealing with the lateral forearm. Versus your axillary. Axillary is dealing with motor of the deltoid, teres minor, and then a lot of the skin and joint capsule of the shoulder. So things that whole axillary region. Armpit region here. Median nerve is muscles that pronate the forearm, flex the wrist and fingers, and then also do opposition of the thumb. Ulnar is dealing with a bunch of intrinsic muscles of the hand. It's also the skin of the lateral aspect of the hand. Helps with wrist and finger flexion, adduction, abduction of the fingers. And then your radial Radial is actually the largest branch of the plexus, and it deals with tons of the posterior skin of the upper limb and the extensor muscles. So make sure you know those 5. Those branch off and form your various different nerves. You will have to recognize all these nerves for lab. Lumbar plexus. Our lumbar plexus is L1 through L4, and it's mainly going to innervate our thigh, abdominal wall, and the psoas major muscle. And that is going to form your femoral and obturator nerves. Your femoral is your anterior thigh, as well as the skin of the medial leg, foot, hip, knee. So there's quite a bit there. Versus your obturator is just adductors, ADD, adductor muscles. That's what this looks like, right? Your lumbar plexus, L1 through L4. And then we get into our sacral plexus. Now the sacral plexus, L4, L5, as well as the sacral nerves there, those are going to form your sciatic nerve. Now, the sciatic nerve is really 2 nerves composed of 2 nerves. Those 2 nerves are your tibial nerve and your common fibular nerve. Your tibial and common fibular make up your sciatic nerve, and it is a big fat nerve, and that branches all the way off this lower region and comes down through this region. And we talked about it when we talked about the muscular system, right? Because right through here we have the piriformis muscle that can put pressure on that and cause irritation to that sciatic nerve that goes down. But we can also, if there was injury here in the part of the spine, that could also affect the sciatic nerve. It is the longest, thickest nerve of the body. Here's what that would look like going all the way down, and then it starts splitting off into your common fibular and your tibial nerve. And those are your main plexuses, plexi. Innervation to the back and the anterior lateral part of your thorax abdominal wall. That is going to be innervated by your dorsal rami. And it is mainly that T1 through T12 that we talked about. Those aren't remember, everything else is going to form plexuses. So all the other ones, this is where we can innervate this whole abdominal thoracic region. Now, there is this interesting thing where we have branches of nerves that are forming these plexi and the rami coming together. Well, there is these specific nerves that come off the spine that I talked about, right? And those were where they were coming out, very specific. We numbered those like C1, C2. A lot of these nerves through here are going to be grouped together. So these would all group together to form a plexus. Well, these nerves, the sensory portion that's coming, they're very specific and individual. Their sensory is not so combined together like the plexus is more of like that motor. Well, here we have these very specific sensory to the skin, and those are our cutaneous sensations. And the cutaneous sensations are, you're going to see form specific patterns called dermatomes. Dermatomes, let me get through here, are dermatomes, where are we? Are areas of the skin's innervated by these branches of a single spinal nerve. And we can test those. So if you look on the body through here, this is C2, C3, C4, C5. And then we can test that dealing with light sensation, pokes and pries. Have you guys ever seen the pinwheels? They're little, they're tiny. They're like about this big, and then they have little spikes on them. It would look something like, let me see if I can draw a picture of it through here. If I drew a picture, you would see it has a little handle like so. And then on that handle is a wheel, and then off of that wheel are spikes. Oh, that is awful. Are these spikes that come off of it like this. And then they would wheel that along different parts of your body. So this is a great neurological test where they would actually take a little pinwheel and go down different parts of the arm. We'd come down through here and come across different portions. And that's how they test whether certain nerves are irritated and why where the specific location of that is. And they'll do compare side to side. Does this feel the same as this? Comparing the sides of the body. And they'll do light touch, soft touch. They'll do the pinwheels, which is more pokiness, and they'll also take a Q-tip, which is more softness, and those are different cutaneous portions of that. And that's checking what we call dermatomes. So they use that in a lot of neurological tests, and that is the pattern for that. So just know for a dermatome, the dermatome is the area of skin innervated by a specific nerve. You do not need to memorize this chart. Don't need to know that. Maybe if you're specializing as you start getting into neurological exams and later on into some other disciplines that you guys are going into, then you would have to know this, but not for this exam. Okay? And then that brings us down to the last little bit, our reflexes. So all this information that we've talked about so far is sensory input from the peripheral area coming into our spinal cord or central nervous system, and that is getting processed in our higher learning, whether it's our cortex or even our brainstem. We're dealing with the central nervous system. However, there is these things called reflexes where we're going to have information come in from the periphery, go to the spinal cord, and right back out, and it doesn't travel up to higher learning. It's an automatic reflex. And when we're dealing with reflexes, we can actually learn reflexes. A lot of our reflexes are just automatic, right? Like those knee-jerk reflexes, where if we hit the patellar tendon on a knee, let's see if I can do it standing up here. So here's my knee, right? And I have this little thing where we hit it and then all of a sudden the foot extends out, and like those little reflexes. We have reflexes throughout our entire body. We're born with those reflexes. However, we can learn reflexes as well. An intrinsic reflex is something we're born with. An acquired reflex is something we learn. So there's reflexes like if we're really been driving for a long time where we'll see something and we don't think about it and we'll move out of the way or brake when something's in front of us. It's not something that we have to think about. It's an automatic reflex, okay? But I want to talk a little bit more about this intrinsic reflex. You drop a boiling water or touch something really hot, like the body pulls back on it. Little kids, even if they've never had that experience, they're going to pull back on it. It is a natural reflex, okay? So how does that reflex work? Reflexes can be intrinsic or acquired, as I mentioned. They're dealing just with those peripheral nerves and then the spinal cord. It does not go up to our brain. However, here it says it involves higher brain centers as well because we're aware of it. It's not like something moved and we weren't completely unaware of it. It's just we're having a motor response faster than our brains can interpret that information and make a logical decision. It's a quick thing. So it does involve some higher brain centers, but mainly that peripheral nerve and spinal cord, right? Let's look at that. Here's how it would look if we're bypassing it. If we get a stimuli that is dangerous, that sensory goes to the spinal cord and immediate goes right back out to that effector motor neuron and effector muscle to pull back, get away from that dangerous stimuli. Yep. Now, a lot of these reflexes deal with these two different receptors, which we call muscle spindle fiber and a Golgi tendon organ, which are they're both types of receptors, muscle spindle, Golgi tendon organ. And we've talked a little bit about this in the muscular system, where the Golgi tendon organ is measuring tension in the body. So anytime that muscle really starts contracting, it's going to pull on the tendon because that's going to be pulling on bone. And when that gets tension, because the muscle's contracting, it's going to have an automatic reflex. Just try telling the muscle to not contract, to loosen up, to calm down. And so that helps create this muscle tone. And the very opposite of that is your muscle spindle. And the muscle spindle, the moment this muscle gets stretched, there's a reflex to tell it to contract. They are completely opposite of one another. Now, the stretch reflex deals with if we stretch a muscle, that's going to activate our muscle spindle. The result is it excites that stretch muscle, meaning it tells it to contract, but it also tells the opposite muscle to relax. The Golgi tendon organ, once that muscle contracts, it's going to be activated by increased muscle tension, and that is going to tell the contracting muscle to relax. It inhibits it, and then it excites the opposite, the antagonistic muscle. Let's look at the knee jerk reflex. That involves primarily your stretch reflex, okay? So these three charts kind of show the same thing for that. Way this works is, here, let's look at it. One, we are getting over through here, we hit that patellar tendon. That causes this muscle, because the muscle is attached to this tendon, it causes it to stretch a little bit. If it stretches, that muscle spindle feels that stretch. Sensory goes to the spinal cord, and it does two things. One, it is going to excite, that's why you see this little positive, it's going to cause an excitatory response to that same muscle to contract. So if it's stretched, it tells this muscle to contract, but it also sends an inhibitory response to the antagonistic muscle, the hamstring, to relax. Thus, it is fast. We don't use higher learning to think about it, and if this contracts, our quad contracts, and our hamstring relaxes, the knee will go into extension, the knee jerk reflex. All right? And that would be your peripheral nervous system.